Everyone knows the sun dies in 5 billion years. That number is real, and it has almost nothing to do with when life on Earth dies. So how long does life on this planet actually have left? Because if that famous number isn't the real deadline, then something closer, something truer, is already ticking beneath your feet. The sun has roughly 10 billion years of life in total, and it will spend only a fraction of that hosting anything alive at all. You are not standing near the beginning of that fraction. The real number is stranger than 5 billion, and it is a lot closer than you think. Here's the honest first answer. The sun does not need to die to end life on Earth. It only needs to keep doing what it's already doing. It is roughly 30% brighter right now than it was when this planet formed, and it is gaining about 1% more every 100 million years. That is a real clock, and it has been running the whole time. But brightness alone doesn't kill a forest, or an ocean, or a microbe. Heat is only the trigger. So what actually pulls the switch? Earth has a thermostat, not a metaphor for one, an actual physical dial. And the thing turning it is a slow trade of carbon dioxide between the sky and the rock. Warmer air speeds up the chemical weathering of exposed stone. That weathering pulls carbon dioxide out of the atmosphere and locks it into carbonate rock. And less carbon dioxide means less warming, which slows the weathering back down. It's a loop that corrects itself, and it has held this planet's temperature in a livable range for billions of years. So what happens to that dial as the sun keeps getting brighter? It keeps compensating, the only way it knows how, by pulling carbon dioxide down, further and further, forever. So what happens when a thermostat has to keep turning the dial down, forever? Every degree the sun adds, the cycle answers by stripping more carbon dioxide out of the air. And for a long time, that trade works perfectly. Atmospheric carbon dioxide right now sits near 400 parts per million. The cycle is going to walk that number down for hundreds of millions of years, quietly, correctly, exactly as designed. But the dial has a flaw. Plants need some minimum amount of that same gas to run photosynthesis at all. Most trees, most crops, nearly every plant using what's called the C3 pathway start failing somewhere near 150 parts per million, and current estimates place that crossing around 170 million years from now. Picture the world at that point. Still recognizably green from orbit, still full of forests, and yet the dial has already reached the number where whole categories of plant life simply cannot pull enough carbon out of the air to survive. That sounds like an ending, but it isn't quite. A second kind of plant, the C4 pathway, grasses, maize, the crops built for heat and drought, can keep running down toward 10 parts per million, wringing use out of nearly the last molecules of the gas. Current estimates place that second crossing around 840 million years out. That's not a footnote, that's a second world, one where every forest on Earth has already gone quiet, and grasslands alone are still doing the work of keeping the planet green for hundreds of millions of years longer than anything with bark and leaves. And here is the turn worth sitting with. The thermostat never breaks. It works exactly as designed, all the way down to nothing, and that perfect performance is precisely what starves the forests, and then the grasses after them. But running out of room on that dial was never the real question here. What happens to the oceans once the thermostat has nothing left to give? High in Earth's atmosphere sits something called the cold trap, a layer that currently catches rising water vapor, freezes it, and sends it raining back down before it ever gets higher. It's the reason Earth's water has stayed on Earth for 4 billion years. But past roughly 1 billion years from now, models put Earth's surface crossing the boiling point of water, and long before that, the sun will already be bright enough that the cold trap stops holding. Water vapor starts slipping through that failed trap into the upper atmosphere instead of falling back down. Once it's up there, ultraviolet light tears the water molecules apart, and the freed hydrogen, the lightest thing there is, simply escapes to space. That happens over and over, one molecule, one hydrogen atom at a time, for hundreds of millions of years. Earth doesn't boil away in some dramatic instant. It leaks. Slowly, quietly, atom by atom, until the blue is finally gone. But losing the oceans still isn't the ending. Something keeps going, hidden long after the surface has nothing left to give. So what's actually left once the water itself is gone? The answer is more than you'd think, and in stranger places than you'd guess. Microbial life keeps going in shrinking hypersaline pools, in caves, in pockets that hold onto moisture the open air no longer can. Life has always been good at finding the last wet corner of a dying world, and this is that instinct playing out on a planetary scale. Push further down, and you find life running entirely underground, deep in the crust, drawing energy from the planet's own heat and from radiation breaking rock apart. A kind of living that owes nothing to sunlight at all. That kind of life could plausibly persist 2, maybe 3 billion years from now, long after the surface above it has gone completely silent. Whatever is doing that, living down there, will outlast every ocean, every forest, every blade of grass that ever grew on the surface above it. It ends only when the planet's interior finally cools enough that plate tectonics itself slows to a stop. Without that motion, the carbon cycle stops completely, and the dial doesn't hit zero. It simply stops existing, because the machine that turned it is gone. That last ending has nothing to do with the sun at all. It's the planet's own engine, finally running out. So, how long does life on Earth actually have left? Complex life, the kind you'd recognize, forests and animals, and anything that needs real air to run on, has roughly 500 million years left. The biosphere as a whole, life in any form at all, likely holds on for 1 to 2 billion years beyond today. And the 5 billion years everyone opened this video already knowing, that number is real. But it was never our number. It belongs to the sun. Earth has been alive for around 4 billion years, and it will sit sterile for at least 4 billion more before a red giant is even relevant to anything. This planet spends the majority of its existence dead. The stretch we're living in, right now, is the anomaly in the middle, and none of that would make sense without the thermostat that's been running underneath it the entire time, turning steadily, then pinned at its floor, then finally gone. Which leaves one more piece of scale worth holding. Animals have existed on this planet for around 600 million years, and the years remaining for animals stretch out to roughly that same distance again. We are not near the start of that window. We are past its middle. And somewhere in that generous back half, one species on this small blue dot looked up, worked out the rock, the light, and the air well enough to calculate its own planet's expiry date. And that isn't a bleak thing to know. It's a remarkable one. There's more of this story left to tell, more deep time, more strange chapters written into rock and light and air. We'll keep looking. This is small blue dot, and the dot is still turning.